Chapter 28. The Storage Bill Surprise. Tom had submitted the savings plan for EC2. The next line on the bill was S3, $198 a month, down from $847 after the lifecycle policy changes from Chapter 23. Then he looked at EBS, $440 a month. That seems high, he said. Leo pulled up the EBS volume list. There were 47 EBS volumes attached to instances, and then there were another 23 volumes not attached to any instance. These 23 volumes, Tom said, what are they? Leo looked them up. They were all detached. No instance was currently using them. Most had been created from snapshots for debugging purposes. Some were from instances that had been terminated, but whose volumes hadn't been deleted. We're paying 10 cents per GB per month for storage no one is reading, Leo said. Tom looked at the total, 2.3 terabytes of unattached volumes. $230 a month for storage we're not using, Tom said. How long has this been going on? Leo checked the creation dates. The oldest volume was from 16 months ago. $3,680, Tom said quietly. We've spent $3,600 on storage no one accesses. He deleted the unattached volumes. The following month, the EBS bill dropped to $210. The storage cost audit. Tom's EBS discovery was a symptom of a broader pattern. Storage costs accumulate invisibly. Unlike compute, you notice when 47 servers are running. Storage silently adds up. Think of it like a storage unit rental. Renting one unit is obvious on the credit card statement. But if you rent a second unit for a project, then a third for some old furniture, and you never go back to check what's inside, the charges keep appearing every month, quietly, long after you've forgotten what you're even storing. Cloud storage works the same way. The bytes sit there, the invoice arrives, and nobody questions it until someone finally opens the door and finds it full of things nobody needs anymore. A thorough storage cost audit looks at S3. Are lifecycle policies in place for all buckets? Are there old snapshots, RDS, EBS sitting in S3? Is intelligent tiering appropriate for any buckets with uncertain access patterns? Are there versioned objects creating multiple copies that are never accessed? EBS, are any volumes unattached, no running instance using them? Are GP3 volumes properly configured? Default GP3 volumes may have excess provision throughput/IOPS that isn't needed. Are snapshots older than necessary being retained? RDS, are automated backup retention periods set appropriately? Longer, more storage cost? Are manual snapshots from old instances still sitting around? Are read replicas from database migrations still running? EFS, is the EFS volume in the right storage class? Standard versus infrequent access. S3 versioning, the hidden cost. In Chapter 5, we mentioned that S3 versioning keeps every previous version of an object. This is excellent for safety. It's terrible for costs if you don't also have lifecycle rules for the versions. When versioning is enabled on a bucket, every time you overwrite an object, the old version is retained. Over time, day 1, image uploaded, V1. Day 30, image updated, V1 is now a non-current version, V2 is current. Day 60, image updated again. V1 and V2 are non-current, V3 is current. Day 365, V1, V2, V3, V12 are all stored. You're paying for 12 copies of an image. The fix. Lifecycle rules for non-current versions. Code example omitted for narration. Tom applied these rules to all versioned buckets. The following month, S3 storage decreased by 18%. EBS, right-sizing and the GP3 upgrade. EBS volume pricing has two components. 1. Storage per GB per month. 2. Provisioned IOPS and throughput, if you're on IO1, IO2, or paying for extra GP3 performance. The GP3 opportunity. In Chapter 6, we noted that GP3 is the current default and is cheaper than GP2. If Nimbus had volumes created before GP3 was available, it launched in December 2020, those might still be GP2. Tom found 12 GP2 volumes totaling 1,200 GB. Migrating to GP3 saved 20% on those volumes immediately, with no performance degradation. IOPS and throughput. GP3 volumes come with 3,000 IOPS and 125 megabytes per second throughput by default, at no extra charge. You can provision more if your workload needs it. Review whether provision performance is actually being utilized. Tom found 2 GP3 volumes with 10,000 provisioned IOPS. He checked the CloudWatch metrics. Actual average IOPS was 1,200. He reduced the provisioned IOPS to 4,000, a safety margin above the actual peak. Monthly saving, $68. Snapshot lifecycle. EBS snapshots are incremental. Each snapshot only stores changes since the previous one, but they accumulate. Old snapshots from the early days of Nimbus still existed. Tom kept 30 days of daily snapshots and deleted the rest. EFS, storage classes. Amazon EFS has its own storage classes. EFS standard, for files accessed frequently, higher cost. EFS infrequent access IA, for files not accessed for 30 days, 92% cheaper than standard. EFS archive, for files not accessed for 90 days, even cheaper than IA. EFS intelligent tiering, automatically moves files between storage classes based on access patterns. Tom enabled intelligent tiering on the EFS volume. 6 weeks later, 68% of the files had moved to infrequent access. Monthly EFS cost dropped from $89 to $31. S3 cost allocation tags, finding who's spending what. As Nimbus grew, multiple teams were storing data in S3. The analytics team had their own buckets. The engineering team had their buckets. The restaurant data team had their buckets. The bill just showed S3 $198. There was no breakdown by team. Cost allocation tags let you tag AWS resources with business metadata, team, project, environment, and then see costs broken down by those tags in AWS Cost Explorer. Tom added tags to all S3 buckets, code example omitted for narration. After a billing cycle with tagging, he could see the analytics team's data lake is $74 a month. Engineering backups are $43 a month. Restaurant data is $81 a month. Now he could have budget conversations with each team instead of just looking at an aggregate number. AWS Cost Explorer and AWS Budgets. AWS Cost Explorer visualizes historical and forecasted costs by service, region, tag, and usage type. Essential for understanding where money goes. AWS Budgets sets alerts when costs exceed or are forecast to exceed a threshold. You can budget by service, region, tag, or account. Tom set up 3 budgets. 1. Total monthly bill, alert at 90% of the budgeted amount. 2. EC2 on demand, alert if on-demand spend exceeds $500 a month, signals a savings plan gap. 3. Data transfer out, alert at $200 a month. Data transfer costs can spike unexpectedly. The budgets sent alerts to a Slack channel. The team saw when they were approaching limits, rather than discovering it on a monthly invoice. The cost of neglect. Tom built a spreadsheet. He calculated how much Nimbus had spent on unattached EBS volumes, 16 months, $3,680. Old S3 snapshots, discovered and deleted, $890. Unneeded provisioned IOPS, $816. GP2 to GP3 migration savings, projected if done earlier, $2,160 over 18 months. Non-current S3 versions accumulating, $1,340. Total waste identified, approximately $8,800 over 18 months. $8,800, Maya said. From neglect, Tom said. Not from making wrong architectural decisions, from not cleaning up. What's the systematic fix? Regular audits, Priya said. Monthly Cost Explorer reviews. AWS Trusted Advisor flags unattached volumes and idle resources automatically. Automate the cleanup of known waste patterns. Delete snapshots older than N days. Alert on unattached EBS volumes. Expire old S3 versions. And, Tom added, make cost hygiene part of the deployment process. When an engineer terminates an EC2 instance, the EBS volume gets deleted automatically unless they explicitly opt out. Strengths and limitations. Cost optimization discipline. Regular reviews catch accumulating waste before it becomes significant. Tagging enables accountability. Teams see their own costs. Automated alerts prevent billing surprises. Lifecycle policies and right-sizing are often set-and-forget savings. Where it gets complicated, identifying waste across a large account with many teams requires centralized tooling. Some waste is intentional, keeping extra snapshots just in case. The cost-risk trade-off is a judgment call. GP3 migration requires careful validation. IOPS and throughput defaults may differ from GP2 behavior in some edge cases. Cost allocation tags require discipline across all teams. Inconsistent tagging makes the data incomplete. Summary: storage costs accumulate invisibly. Regular audits are essential. Unattached EBS volumes are a common source of waste. Delete them, or automate deletion when instances terminate. EBS right-sizing. Migrate GP2 to GP3, typically 20% savings. Remove excess provisioned IOPS. S3 versioning. Enable lifecycle rules for non-current versions to avoid paying for unlimited version history. EFS intelligent tiering. Automatically moves files to lower-cost tiers based on access frequency. Cost allocation tags. Tag resources with team project environment metadata for cost visibility and accountability. AWS budgets. Proactive alerts when costs approach thresholds. Never be surprised by the monthly bill. Exam tips. SaaS03 domain. Design cost-optimized architectures. Task 4.1. Cost allocation tags. Enable user-defined tags for cost allocation in the billing console. Then tag resources. Cost Explorer shows breakdowns by tag. Exam scenario. Identify which department is generating the most S3 costs. Cost allocation tags. AWS Trusted Advisor. Identifies underutilized EC2 instances, unattached EBS volumes, idle load balancers, and other waste. Basic checks free. Full checks require business enterprise support. EBS cost components. Storage per GB. Provisioned IOPS if IO1, IO2, or extra GP3. Throughput if extra GP3. Know which components can be right-sized. S3 versioning costs. Non-current versions are stored and charged at the same rate as current versions. Lifecycle rules that expire non-current versions are critical for cost control in versioned buckets. AWS Compute Optimizer analyzes EC2 utilization and recommends right-sized instance types. Exam signal: reduce EC2 costs by selecting the right instance type. Compute Optimizer. AWS Cost Anomaly Detection uses ML to detect unusual spending patterns. Exam signal: automatically detect unexpected cost increases. Cost Anomaly Detection. Exercise 1 Recall. Explain why unattached EBS volumes generate costs even though no EC2 instance is using them. What process should engineers follow when terminating an EC2 instance to avoid this waste? Hint: EBS volumes store data on physical disk, and that disk costs money regardless of whether it's being read. Exercise 2 Exam Practice Scenario. A company's AWS bill has grown from $5,000 to $9,000 a month over 6 months, but they haven't added new services. The engineering team suspects storage costs are the issue. Which combination of AWS tools would best identify and explain the cost increase? A. AWS CloudTrail to review API calls and identify who created new resources. B. AWS Cost Explorer for service-level cost breakdown, and AWS Trusted Advisor for idle and unattached resource detection. C. Amazon CloudWatch for monitoring resource utilization and creating cost alarms. D. AWS Config for identifying all resources and their compliance status. Hint 1. Identify the cost increase. Visualize cost breakdown by service. Hint 2. Idle and unattached resources. A specific tool proactively identifies these. Hint 3. CloudTrail logs API calls. Cost Explorer shows cost trends. Which is more useful for cost analysis? Answer B. Explanation. AWS Cost Explorer shows cost trends broken down by service, region, and usage type. Perfect for identifying which service drove the increase. AWS Trusted Advisor's cost optimization checks identify unattached EBS volumes, idle EC2 instances, underutilized load balancers, and other common waste sources. Why not A? CloudTrail logs who created resources and when, but doesn't directly show cost trends or identify waste. Why not C? CloudWatch monitors resource performance, CPU, memory, useful for right-sizing but not for identifying accumulated storage waste. Why not D? AWS Config tracks resource configurations and compliance, but isn't a cost analysis tool. SaaS03 domain. Design cost-optimized architectures. Task 4.1. Exercise 3 Architecture Challenge. Nimbus's S3 bill shows $340 a month for a bucket labeled Backups. The bucket has versioning enabled and contains daily database snapshots. 7 days is enough for their policy. Weekly full backups, kept for 3 months. Quarterly archives, kept for 7 years for tax compliance. Design a lifecycle policy for this bucket. that minimizes cost while meeting these retention requirements. What storage class should each type of data use? How would you handle versioning to prevent old versions from accumulating? There is no single correct answer. The goal is to practice lifecycle policy design. Post-credits scene, Tom published the cost audit findings to the team. Waste identified, $8,800 over 18 months. Expected annual savings from changes implemented, $6,200. Then he added a line at the bottom. This does not include the savings from savings plans, $14,200 a year, or S3 lifecycle policies, $7,800 a year. Combined annual optimization impact, approximately $28,200. Maya read it twice. That's almost a junior engineer's salary, she said. In waste, Tom confirmed. Or, Leo said, it's proof that doing these optimizations earlier would have funded that junior engineer. Tom looked at him. That's the right way to think about it, he said. Cost optimization isn't about cutting, it's about not paying for things that don't create value. Maya pinned the document to the company wiki. In the next chapter, the database tier gets the same treatment, and Tom discovers the one place he was actually underinvesting.